What's up?
Ours would be AR, right?
Well, ours is probably neither.
Oh.
I think ours is just a yeah, augmented. Yeah, it's not AR or VR. It's just R.
Well,
Well,
technically
not
you don't
necessarily.
have
I don't know
to,
if I'd call it R.
technically you don't have to have a 3D model for it to be virtual reality. It just has to be a reality that is virtual.
Right. Well, so but augmented. So if we go augmented reality actually adds to your reality. We've actually removed from our reality.
Right. So it would be more virtual reality than augmented reality, or virtual simulated.
Yeah.
Simulated.
Yeah, if you could.
I'm thinking more like degraded reality. It's a reduced reality.
Yes. If you just call it R, then you just call it reality. Then we're actually in the Matrix. So then.
Right.
But
Exactly.
If we're
If our
just going to
code
call
is
it
the
R, then
reality.
shouldn't we be coding it in R?
Well, I mean, R is actually a language based on Java, so it's pretty.
Right.
This isn't so far dissimilar from that.
So we could have R in
Okay, so we talked last time, and let's see, do we have the ability? Let's just go down and review real quick what we're doing down here. So we built all our rooms, right? So we have our one player, we have all our different rooms. Then we went ahead and linked up our rooms with all the exits, all those destinations. Now, realistically, later on, we might go ahead and kind of put this inside of like a dungeon object or something like that, where a lot of this detail is hidden from us up top. So down below, we just kind of have a player, and we have computer science department object, and the player enters computer science, and they show up probably in the main CS hallway or something like that, and end up looking around from there. And we might add that today. That's the idea of encapsulating our code, taking a bunch of details that we don't need to work with. This goes back to that the example of the telephone, right? We have all these wires here, and this is all working. So now let's take those wires and stuff them into an object. That way we don't need to see the wires laying around anymore. Because realistically speaking, we've basically mapped out the whole department, right? So this telephone has been built. And while we might go in and make some modifications, we're not heavily working on it right now. So we can go ahead and put it inside of the a case and say it's good. Okay. So then we go ahead and we add our player to the first room. We have the player then look around, and when a player looks around, so remember when we added a player to a room last time, the player gets added to that room's list of players, but then the room also lets the player know that you are in this room. So the player lets them know about themselves. So let's go and look at add player. So here's add player, where the player gets added to their list of rooms, but then the room itself lets the player know about themselves. All right, so that way the player has a pointer to the room that they currently are in. So when they look around, they effectively say, room display yourself. And the room shows itself to the player or something like that. Kind of make sense? Okay. So player gets added, then they look around seeing the room that they were in. Then we remove the player from that room, tell them to look around again, and now they should be, when they leave the room, we go ahead and unset that pointer. We set it back to none, which means they're currently in flux. I think we said they're in the ether, and we had some controversy over the spelling, but whatever. Okay, so they've been removed from the room, but they haven't quite gotten to a new room yet. Right, so they're currently in the ethers, and when they look around here, they are currently not in any room. Then we'll go ahead and add them to the CS hallway, and we'll have them look around again. All right, so that's kind of our mechanical move of what it takes to enter a room, leave that room, and enter another room. Okay, those are the moving parts that we want to automate through some sort of menu system. Okay, where we can ask the user, they look around, they see what the obvious exits are, then we say, what do you want to do? Or which direction do you want to go? That kind of thing. Okay, so let's go ahead and get our player's show menu. Okay, so here's our show menu. What would you like to do? Right now, we're asking him, do you want to hit or heal, right? Okay, well, that was when they were just standing in a single, well, we didn't even have a room. They were all just standing there fighting. Now we want to augment that a little bit, but let's take out the hit or heal part of it for right now. We'll end up bringing them back together, and we're just going to say, where would you like to go? Something like that. Okay, where we're asking them based on the directions where they would like to go, and they're going to enter something in. Okay, so the player will show their menu, will read something in, it will return what they read in, and based on what they read in, we want then them to either take that exit or scream and say there's no door there or something like that, right? So if I say up in any of our rooms, I don't think we actually had any directions going up, although we probably will build a treehouse in the lab, I'm assuming. But in any case, if they say up, it should probably come back and scream and says, unfortunately, there's no door up there or something like that, or you try to jump and fall on your butt, something like that. Okay, so let's go ahead, and before we just randomly do this, let's put the logic in here. So we'll go ahead and add the player, tell the player to look around, then we'll go ahead and say P1 dot show menu. Okay, so the player will show the menu and get some input. The input that we get, maybe we call that where. Okay. So we call that where, and that's going to be wherever is returned from show menu, which should be a destination. Now, once we have that direction, we need to tell the room we're currently in the direction we'd like to go. Right? So we need to add a function to a room, maybe called take exit, something like that, where we pass in the exit we want to take, and it looks up to find out if it's a legitimate exit first. So we're going to pass in a string, find out if the string matches one of our exits. If it does, we'll go ahead and do the necessary steps of having them enter that new room, which first makes us leave this room. Then we'll take the exit. Otherwise, we're going to scream at them and say there's no door in that direction or something like that. All right, so let's go and augment room. So here's room. So let's go ahead and we'll say def take exit. All right, and that'll take in a direction. So presumably the word they typed in. All right, so the first thing we want to do is we want to find out if this is a legal direction. How do I ask the question? Is the direction they gave us a legal direction? Remember, in our rooms, we have a dictionary of destinations. How do I find out if the direction they gave me is a legal direction to go? Okay, it has to be a legitimate key in that dictionary. How do I test that? Huh?
Do you need a search for it?
Okay, how?
With the search function?
Okay, let's keep going down that path. What do you have a specific search function in mind?
No, but I would what I tried to do was use a while loop, or no, an if statement, and then have it find if have it in quotes north or south.
Okay, let me ask you this. So we're going to call this, let's call it, room destination. Okay, and the name of our dictionary is called destinations. So we're going to say self dot destinations at bucket direction. Okay, so this is my dictionary. I'm saying give me the value in that dictionary at bucket, whatever direction is. So direction is our key, right? So we're looking up the value associated with our key. Dictionaries are key value pairs. What kinds of keys are in our dictionary and what kind of values are in our dictionary? When we built this dictionary, what did we put in there? Go ahead.
The keys will be north, south, west.
Strings, yeah, strings related directions. Okay, and what are the values that are associated with those?
The object.
Room objects. Yep, specifically room objects. Okay, so our destinations dictionary is going to be filled up with a whole bunch of keys, which are strings, and then values, which are rooms that those strings lead to. North is this room. South is this room, so on and so forth, right? So I'm trying to say, give me the room associated with this key. What are the possible results I will get from that? I'll either get a real room, right? If I said north and there was an exit to the north, I'll get some room. If it was south and there was an exit to the south, I'd get a different room. What if there wasn't? What if this key wasn't found? What would I get out of this? None. If I try to look up a key that has no value, it gives me a value of none. I didn't find it, buddy. Okay? So we can ask the question, if, well, actually, let's go ahead and we'll keep this value like this, because that way you don't have to look it up twice. So now we'll say if room destination is equal to none, and none is a constant. It's a constant. So this isn't the string none. This is the nothingness value, which is none. Okay, it's like a variable name that you're not allowed to steal. It's built into the language. Okay? So if room destination was none, that means we have nothing to do. You gave me a bad exit. So we'll go ahead and say print no exit found or something like that. Usually MUDs are a little goofier than that. They'll say like you spun around and fell on your butt or something like that. They might be, they usually operate off of like the direction you went. So if you say up, you try to scale the wall and then you fall backwards, that kind of stuff. But we'll just say no exit found so we can keep it simple. All right. Otherwise, an exit was actually found. And what do we do if an exit was found? We actually have a real room. So if we're in this room and we're trying to go to the north, okay, we're going to get inside of room destination the room that is associated with our CS hallway. Okay? And I want to get into that room. How do I get into that room? What are the mechanical steps it takes for us to get into that room? Go ahead.
You remove yourself from the old room and then set the new room.
Okay? So get out of this room first, then get into that room. All right, so let's do the 2 steps here. So we'll say remove ourselves from the current room. All right. Now, the current room I'm in is the room whose take exit I called, right? If I'm in S120 and I type in north, I then ask the room, I would like to take the exit to the north. And this would be kind of weird to do this in real life. I'd encourage you to maybe go through about a 2-hour period today of doing this and just seeing how society looks at you. This is coming from an adult who carries around dolls. So, I'm already, I have a baseline I can compare it to, and I can tell you that people are often quite accepting of the doll because they just assume there's a kid in tow. Then it gets weird when they don't find a kid. All right, so I would do this. It's like, room, I would like to take the exit to the north. And then you're just kind of waiting for the room to beam you in there. That would be awesome. Okay? But even though this is funny to talk about like this, you really have to start thinking about programming like this. Okay? Because remember way back at the beginning of the semester, I talked about how you need to rewire your brain, how you think about how to think like a programmer. Because we're so used to thinking like people that we skip all these little meat and middle steps. Okay? In real life, if I said go into the CS hallway, you just walk over there. You don't think anything of it. You don't think about the process of leaving this room and entering that room. In fact, the room is an inanimate object. You don't think anything of it. Okay? But we have to kind of sort of give personalities to all of our objects in our virtual worlds. Okay? So even though to us, this room is nothing more than just a space to occupy, in the programming world, the space doesn't have feelings but has abilities. Okay, so we're going to say out loud, S120, I would like to leave you to the north. S120 will then go and look up and see, to the north, I actually have a real room, and it's called CS Hallway. They won't actually know it's CS Hallway. It'll be just some memory address. It's like, okay, I have the room right here. So what's the room going to do? It's going to first remove you from the room. Okay, so I'm standing here just waiting. Okay, I've made my request to the room. People just assume I'm talking to myself. The first thing that happens, as you pointed out, is the room removes me from itself. Okay? So we're going to say self, that is the room I'm currently standing in. Now, what would a synonym, let me write the line first. I'm going to ask you to tell me a different way of writing the line that means the same thing. It wouldn't be the way I recommend it. I'd recommend this way, but it'll be an interesting exercise. So self, remove player. What player are we removing? We're removing a player. We have a problem here. Take exit doesn't take a player in as a parameter. It doesn't know who we're removing. Now in our current little game, we know there's only one player. Right? So we could just remove the top guy in the list. But what would make the most sense is to go ahead and let's pass in the player that is taking the exit. I would like to take the exit to the north. I say to S120. Okay, so I let S120 know which of us is going to take the exit, because in the future our rooms might have a whole bunch of players in them, right? So I'm going to say S120, I would like to go to the north. So I passed myself in as well as north. S120 looks up the room to the north. It finds a legitimate room, so it gets into this else. And then we're going to tell the room, S120, which is self, that's whose perspective. So we're standing inside of S120's take exit ability. All right. So we're going to say S120, I want to remove the player. Who do you want to remove? Well, remove player. Right here. It's very, very close in proximity, so much that I missed it. This guy requires me to pass in the player who I want to remove. All right, so the player I want to remove is the player that was passed in here. All variables resolve to their most local definitions. So player right here refers to this local variable that was passed in to take exit. And it's going to get passed in to remove player. And it's also going to be called player in there. But it could have been called elephant in there. All right, but the most local definition of player that we refer to right here is that guy. So we want to ask the current room to remove us. All right, and we saw that by removing us, the room takes us out of their list, but also erases our current room. So we're in the ether, as we've put out. All right. Then you pointed out we need to get to our destination. How do we do that? What room are we going to here? What's the name of the variable for the room we're going to here? Room destination. So we want to say room destination. It's that room that we want to add a player to. What player are we adding? Ourselves, the player that was passed in here. So add player, player. Make sense? Now, this line right here. How could I have written that same line in this exact context? So I'm changing nothing with the parameters coming in or anything. How could I have accomplished that identical line? Using different words, I guess. This is really a question about understanding pointers and how different variables both point to the same ultimate place. What is self in our current example? The player that was passed in here is standing in S120. What is self? It's S120. It's the room S120, right? Okay. Do we have any other way of referencing the room S120 other than self right here? So inside of this scope, okay, so I'm inside of S120's version of take exit, and I have available to me the player object as well as the direction I want to go. How else can I refer to the room S120 other than saying self? Go ahead.
Could you do that by going with player dot current room?
Yeah. Okay, so kind of the trick there was we can't use S120. That's a variable that's available out here, right? That's not in our scope. So S120 externally, the equivalent to that is self internally. But we don't have access to S120 out there. But inside of this function here, take exit, instead of saying self, I could say player dot current room dot remove player. And if I'm the player, isn't my current room the same thing as S120, which is the same thing as self? Those are all synonyms to each other right now. I happen to have access to two of the three. S120 is out of my scope. That variable's somewhere else in my program. Okay? But I have access to a player right now, and I can say, okay, you'd like to be removed from your current room, which happens to be self. That happens to be me. So I can either refer to myself by saying self, or I can refer to the room using the player's current room. Those mean the same thing. Does that make sense? So then we just have to choose which way do we say it that kind of makes the most sense. Either one of them is probably okay, but since this is a function inside of the room object, it might make sense for S120 to remove the player from the room. So we'll say self dot remove player. Then we'll go to our destination room and tell that guy to add us. Go ahead.
Does it slow it down because you call correct layer correct room because you call the object layer and then ask it to get what's the code?
So would the alternative, the player dot current room, would that be technically a little slower?
Because it's extra step.
A little tiny. Yeah. I mean, you're right, because you would have to resolve two different variables. We have to resolve player, then we have to resolve the player's current room variable. But I mean, you're talking negligible. You know, those aren't the types of, as a general rule, when we talk about programming, those are not the types of things that we really need to concern ourselves with. We're not talking about a whole lot of data. Looking up a quick variable, just doing a memory map, unless you're doing a billion of them, you're probably not going to notice, even if you're like doing benchmark performance testing type stuff. Okay, so if you really care about it at that level, you probably know what you're doing. But you're right. It is an extra step. I guess what I really want to say there is don't not do it because it's an extra step. If it makes more logical sense to say it a certain way, do it that way, even if it's one extra step. That's probably a good rule of thumb for right now. Don't say something cryptically just to save a step. Say it cleanly and cost yourself the extra step and move on with life. Okay? So remove ourselves from the current room, add ourselves to the destination room. So then out here, we're going to go ahead and we need to, in fact, we're actually going to do the other one here. So once we look around, we say P1 show menu, we'll get the direction we want to go. We need to let the room we're currently in know about the room we want to leave or the room we want to go to. So if I'm standing out here, I might know that I'm in S120, but the only way we can access S120 out here is by saying P1 dot current room dot take exit. Who's taking the exit? P1. And where are they going? Where? This is the player that's taking the exit. This is the destination they're going to. The player, the direction. That make sense? All right, so let's test this for a single move, and then we'll just throw this inside of a loop. Okay, so we are in S120. Possible exits are to the north. If we type in east, oh, we get a problem. Oh, it won't give us a none.
Question.
Go ahead.
For that, couldn't we do if room destination in self.destination's direction? You know, and that kind of just checks that.
Yes, you can. You can do that. I was expecting this to give me a different result. So I was expecting, let's go back up here. When I do this, for it to work regardless, but possibly give me nothing. What it appears like it did is it said, it threw it what's called an exception. So you have a key error. I tried to find east for you, and I couldn't. All right, so what he wanted to do, which would have been somewhat of a jump. So let's just run this real quick in the other way before I show you the fix. So for your homework, you didn't necessarily have to make it work for bad inputs. As long as it works for good inputs, that's fine. So we're going to go ahead to the north. And, oh, I didn't actually show the room. It worked. Let's tell this player to look around again. This should show them their new setting, right? Once we put that in the loop, it would have looked around again. All right, so we'll go to the north, and now we're in the CS hallway with a bunch of exits north, south, east, and west, and the program has ended. Okay? So to handle the bad exit, I was hoping that if I try to look up a key that doesn't exist, it would give me a null value. Instead, it throws an exception. So what he wants to do is he wants to ask this question. If direction in self.destinations, I think that'll work because destinations, if you just print out everything in destinations, it'll be the list of keys. Then let's do the stuff if it does exist. All right, so if the direction we're looking for is in self.destination, which will be a list of keys, if it is in there, this will return true. Therefore, so that's effectively the search function you mentioned before. Then we'll remove the player from the current room, and then we'll get the room that we're going to. So we could have stored that in a variable if we wanted to. Otherwise, we can just use it directly. So that's the destination that we're trying to go to, and we'll add the player to that destination. All right, so let's put in east. We get the no exit found. Run it again. We'll put in north, and now we're in the CS hallway. All right, so the logic works for that. Okay, so now what we'd like to do is we'd like to be able to continue to walk around the department, not just have it happen, one time. So what we're going to do is when we look around, then read in the exit, then take the exit from our current room, we want to repeat that over and over again, where we look around, ask a question, reply, do something as a response to that. Let's put that inside of a loop so we don't have to look around a second time. All right, so for right now, what if I wanted to do this forever? Okay, so I want to do a while loop. While what's true? Just true. So while true, do that. Under what circumstances does the Boolean value true ever become false? It doesn't. So this is a infinite loop. This is a while loop that is always true. Now, having said that, it's probably not considered to be great programming practice to just throw a random infinite loop in here like this. But we do have ways of breaking out of loops. So we can actually get out of this loop if we had to. All right, so let's run this first just to see if we can traverse our room. All right, so we'll go to the north. Now we're in the hallway. Let's go back to the south. We're in S120. We'll go to the north. Then we'll go to the west. We should be in S118. We'll go to the east. We'll go to the north. We should be in the lab. We'll go to the south. So we can walk through the whole department now. Okay. Now we probably want to give a keyword in here that will exit us out of the loop. It'll break us out of the loop, right? So maybe what we do is we, if you enter in a -1 or something like that, the program will end. So that's in that where. So maybe we say if where is equal to -1, break. Okay, we've talked about break and continue, right? Talked about those? Yep, so break breaks us out of the most local loop. Okay, so if we happen to put in a destination of -1, then we're going to break out of that loop. Okay, let's go and run that. So we'll go north. We'll go north. We decide we're done. Put a -1. Program's done. Make sense? Okay. So now, what would make the next logical step? Well, we might say that we want to have a class maybe called, I don't know, just to keep it a little bit, mud-based, let's call it a class called dungeon. Okay, and a dungeon is filled with rooms. Just happens to be that this is the computer science dungeon. Okay? So we're going to have a class called dungeon. All right? And a dungeon is going to have an initializer that it's going to hold a collection of rooms. Does that make sense? You'll have a collection of rooms. Put it where? Below?
Like in the room. Like you have the dentist one.
Oh, I do have it still inside the room. Thank you. Testing you. You got it right. Yeah, so what she's complaining about is I'm about to define a class in the middle of another class. Bad news bears. Yeah, don't put a class inside of another class. It actually is possible in some of our more modern languages, but for right now, it's not possible. All right, so make sure you get past the end of your previous class, and then we can go ahead and put our class dungeon in here. All right, and when we build our dungeon, we're going to go ahead and just a blank dungeon will have we'll take no parameters, and we'll just create an empty dungeon. Now, what is an empty dungeon? An empty dungeon, maybe it has a name. So why don't we do that? We'll give it a single parameter, and we can name our particular dungeon. Okay, so we'll say self.name is equal to name. And then we've decided a dungeon is a collection of rooms. So we'll say self.rooms is equal to the empty list. Okay, we currently have no rooms in our dungeon. Now, we want to be able to add rooms to our dungeon. Now, what does a room require? A room requires a name and a description. Okay? But when we add a room, we also need to add that room as a link from an existing room. Does that make sense? So when we first create computer science, we kind of have maybe the computer science lobby. So maybe there's an initial kind of, you're at the cave entrance to computer science. All right. So a room is created initially that represents computer science. So in our cave, we're going to go ahead and we're going to create an initial room. So we're going to have self.entrance is equal to a room, and a room takes in a name and a description. So we'll go ahead and for the name, we'll pass in the name concatenated with the word lobby, something like that. Okay, and then we'll say at the cave entrance. All right, so we've defined the entrance to this dungeon is a room. And then we have a list of rooms that link off of that sitting inside of an empty list of rooms. Now, what we need to do here is we need to have a way of adding a room. A room takes in a name and a description, as well as a direction where it goes off the lobby. That make sense? Okay, so we're going to say add room. And right now we're just going to do it off the lobby since we're just about out of time. So this will be so add room. We'll take in a name, take in a description, and take in a exit. And this guy should add a room off the lobby with this exit. So for instance, if this room were the lobby, I would add CS hallway, a boring hallway, to the north. And it would do the linking and then add this to my list of rooms. Does that make sense? Now we haven't added a player yet, so this is going to be just, you'll have to test it, you'll have to just add a player to the room or something like that and make sure that they see what they're supposed to see. You'll have to add them to the lobby. But for Wednesday, write add room, which just adds a room to our lobby, which is really something we've already written. We're just moving it from out here into here. Make sense? All right. I will see everybody on Wednesday, and I'll put the current code up on Slack.